Okay, so we've been working in chapter 12, and last time we actually finished an example, and we've been working with these z-scores, as you can see. If you remember, this notion of the z-score, essentially it's how many standard deviations a score is from its mean. The formula down here, if you let x be a data value from another normal distribution, you go through this formula and calculate the z-score. I mean, really in the background, what's actually happening is you're taking that normal distribution and essentially converting it to the standard normal distribution. You're modifying it, in other words. I mean, essentially, because what you're doing is you're subtracting the mean, so the mean of the new distribution you're creating is 0, and the new standard deviation is 1 because you're dividing by the old standard deviation. Hopefully that makes sense what I'm trying to say. I mean, there is a lot more. I've taken a few, not many, stat courses as a math student. I mean, there is a lot more happening in the background than I'm able to go into. What we are going to do, though, is answer certain kinds of questions using z-scores. And before we get to that, I did post it above. I probably should have mentioned it first. But if you remember that empirical rule, which says that about 68% of the data values are within a standard deviation from the mean and so on, there was a picture from the textbook that I shared. Let me just share that again. Just going to get to it right. Wait, no, I got to share it. I mean, it is in the book, so you don't have to copy it down or anything. You know, the book's on Lumen. If I can share it, there it is. Okay. All right. You know, we have this picture, as you can see. Let me just get to that. Yeah, you can see it, right? The empirical rule. But basically, we're going to build on this in that we're going to see how you can find where the percentage of values lie. In other words, if you want to know what percentage of the data values are less than 1.5 standard deviations from the mean. Or for instance, if you have if a data value z-score is 2, what percentage of the data values are less than it? I mean, the empirical rule kind of gives a hint. If you notice the shading in area, and that's actually what we're going to do. We're going to use area under the graph of the normal distribution. So it's actually going to be based on the area under the graph. I mean, it's not obvious at first. It's not obvious, actually. You need calculus to prove this, but it turns out the total area under the graph of any normal distribution is 1. So if you were able to get the area of the region under the graph and above the x-axis, and it stretches out, you know, to the left and right indefinitely, but that total area turns out to be 1. That is not obvious, and that actually takes some calculus to prove. So we'll just have to take that as a accepted fact, basically, for now. But we are going to use area under the graph and above the x-axis to determine what percentage of data values lies to the left, right, or between 2 arbitrary z values. So I'm going to show you. I know it may not make too much sense what I'm saying now, but I will show you what I mean shortly. So let me get back to the notes. Okay. But again, this is just what I'm showing for now. Okay, so that's up. But basically, this is the kind of questions that we're going to answer as indicated here. Basically, if you have a normally distributed data set with a certain mean and standard deviation, and let's say you want to know what percentage of the data is less than a certain value, between 2 values, greater than it, it will be based on z-scores, actually. I mean, I'm also going to show you how to do that using Desmos. I mean, with Desmos, there's probably less of a need of z-scores, but it's good to have more than one method. The book actually also shows you how to do this with a TI-83 calculator. What I like about Desmos is it's free. That's why I didn't ask you guys to buy such a calculator, because I know graphing calculators are pretty expensive. I think they could be like $100, but I figured whether there's a pandemic now or not, I'm not going to ask you guys to buy something like that. And basically the way we're going to solve this kind of problem is in the second paragraph. We could use Desmos, but we are basically going to convert to a z-score and then answer the question for the special case of the standard normal distribution. And it boils down to looking at area. Again, it does take a little bit of work why we can just focus on area, but it turns out it's just based on area. And that's why, again, I presented the empirical rule again to kind of remind you of that. All right, I hope everyone's with me so far. If I go too fast, again, use the hand raise feature. I won't get upset. I mean, I do want to get chapter 12 done, but I don't want to go too fast through the material. Okay. All right, so we have that. Again, I did email the notes to everyone. This is just a visual example, so to say. Suppose we had a data set, right? And let's say the data set was test scores. You know, the test scores were out of 10. And let's say that the data set was normally distributed. It happened to have a mean of 6, and somehow the standard deviation of it was 0.3. So that's given to us. We have a data set which turned out to be test scores. Each test score is out of 10. We have a mean of 6, standard deviation 0.3. We can ask, well, what percentage of the students scored less than a 6? I mean, again, this is not easy, right? Because we don't have all the data in front of us. But we do know that it's normally distributed, so we can go by that. Well, again, essentially what we want is, as I just said, the area under the graph above the x-axis to the left of the mean, which is what's shaded in here. So it's just like I said before, right? We're going to answer the question by considering area. That's basically how you answer this. And again, why is that? Well, that takes a little bit of work, but for now, we just accept it. So we would want the area under the graph to the left of 6. And you can actually answer that right now because remember, well, based on what I told you, because remember the total area is 1 under the graph. Since it's symmetric, the graph, about the mean, the area to the left must equal the area to the right. And since the total area is 1, that would mean this total area would have to be a half, or 0.5. So in other words, it would be about 50%. 50% roughly. I mean, I'll show you another way to get that, a more concrete way, because what I said was right, and I hope it made sense. But basically what I'm saying here is of roughly half of the students, 50% of them scored less than 6, roughly. Okay. And that's, again, what I'm saying up here. Now, we can actually use Desmos to calculate this, to solve this kind of problem. Remember how that thing I told you to leave unchecked, that fine cumulative probability, CDF? Well, that's actually what we're going to use. Okay, now the notes here you should have in front of you. Again, I did email it. What I'm going to do now is go to Desmos. You know, I've shown everyone here how to get to it. So let me do that. Let me just, again, get the Desmos. So I do have to stop sharing this. I don't know how to share more than one thing at the same time using Blackboard. Is there even a way to do it? I honestly don't know. There might be, I just don't know. All right, let me wait, let me share my Chrome tab. There we go. All right, so I'm gonna log in. You don't have to log in again, you know, you don't have to. Here's graphing calculator. Here it comes, and it's here. So what I'm gonna do now, okay, is this. I'm gonna What am I going to do? This. Okay. Let me get to that graph we just looked at. Normal DIST. Again, if you don't, you can type it in like that. You can also find it clicking on the keyboard, going to functions, as you can see, pressing up to DIST, and going here, normal dist. You can do that, and it will give you this as well. In fact, let me just do that here, actually. But now the question is, okay, well, what mean and standard deviation? Well, let me stick with the one that we just looked at. So 6, 0.3. Okay, that's what we're looking at. Now here, okay, this is where the mean is. So let's focus on that. So I'm shifting and holding the graph. I'm going to zoom in, as you can see. Okay, that's a little. That's good. I guess that's. Let me see how. That's fine. Okay. Now again, I'm going to show you how to work with that cumulative probability, that CDF. If you click it, you have there it is. You have max and min, as you can see. Okay, min is basically the minimum, max is the maximum. So if we wanted the area to the left of 6, min, we would leave blank because there is no min, but we would want the max to be 6. And you can see that's what we get. It also gives you the value here, 0.5. So we see visually that this is going to be the area to the left of 6. And we're looking at what percentage of all the students scored less than a 6, which is this. And you can see we have a 0.5. That's our answer. Leaving this blank, you could probably see it looks like there's a minus, and then it looks like a figure 8 symbol. That's actually notation for minus infinity, which basically means it's going to keep on going to the left and never stop. That's basically what it means.